Mrs. Dorsey here. I teach 7th grade math at Sequoyah Middle School, and I'm back with some more math. So the last couple of weeks, we've spoken about like terms, coefficients, constants. Last week, I taught you guys about one-step equations. We did addition, subtraction, multiplication, and division, and I had two-step equations in that lesson, but we ran out of time, so I'm just going to continue on with what I had scheduled for last week. So we have a two-step equation here, and this is generally how you will see those two-step equations set up. So let's sort of review what terms in this equation are. We have 2x, we have a positive 3, equals 9. That's not really a part of our terms. We're just looking at the expression. Our coefficient in this equation would be 2 because it's attached with the variable, which is x. Our constant is 3. So in a two-step equation, you kind of have to ask yourself the steps that you've learned before. First of all, you need to think about opposite operation. And what does that mean? So that means I'm going to do the opposite of whatever the equation is telling me to do. And think back to elementary school. A lot of kids get confused with what operation do I start with first? And if you think back to what we learned in elementary school, we always learned addition first, or at least I did, and my kids did. Then they went to subtraction, and then they went to multiplication and division. So in a two-step equation, that's how you start out. The first step is any addition or subtraction. And I'm not going to look at my 9. That's not what I do. I look at whatever the side the variable is on. So on that side, I have a positive 3 or a plus 3, and the opposite of that is subtraction. Very good. I'm going to rewrite the problem here so you can see it a little bit better. And I like to do my different steps in different colors so that you at home, but mainly my students in the classroom, can see the different steps. So I'm going to subtract 3 on both sides. And don't forget, you've got to cross out the positive and negative 3 because that shows you know those go away because I've moved it to the other side. And so now we just do the math. 9 minus 3 is 6. Bring down your equal sign. Bring down what you didn't use. And in this case, that would be the 2x. Now I go to the second step, which is any multiplication or division. And of course, once you also get to this step, it should look familiar to you because it is a one-step equation. I have 2x, which means 2 times x, and the opposite of times is, once again, very good, division. So I'm going to divide both sides by 2. Now, I write really big and what I think is kind of messy. So if you want to bring this down even farther, or if you are working on a sheet of notebook paper and you want to put lines in between each step, that's fine. So now we're just going to do the math. 6 divided by 2 is 3. So over here, I'm going to have x equals 3. Now, what this means is I have solved for the variable. So if I plug in 3 back into the place of x, and I'll do that right above here in a different color. And remember, this is how we check our solution to see if we've done the math properly. So I'm going to plug 3 back into the equation where x would be, because remember, we solved for x. And if you remember from last week, we spoke about balancing equations. whatever is on the left side of the equation, I want to be on the right side of the equation. And I spoke about the scales of justice, because that's what I think about when I think of balancing equations. So 2 times 3 is 6, and 6 plus 3 is 9. I'll write it above here since I've got my funny little picture. And if you see, our equation is balanced. So that is how you can check your work to make sure that you have properly solved the equation. The what? Green? Okay. I'm being told green does not show up very well, so we are not going to use green. Okay, so here we have another equation. 4x plus 3 equals 19. I'm going to rewrite it. And I will just use black this time. So our first step, what do you think we're going to move first? If you said 3, you'd be correct. It's a positive 3, so we're going to turn it into a negative 3. Don't forget to cross that out to show that you know it goes away. And then we just do the math. 19 minus 3 is 16. Bring down your equal sign. Bring down what you haven't used. And we've now come to the second step, which is any multiplication or division. In this case, we're going to divide because we already have multiplication going on. So we're going to divide both sides by 4. And we will just do the math again. So 16 divided by 4 is 4. And I'll write it over here. I have students ask me, do I have to write the variable equals? And the answer is yes. That's what I tell my students. I need to know that you know what variable you've solved for. So I'm just going to circle my answer just because. So once again, if you guys have any questions, you can log in to, was it YouTube?
YouTube RSU TV.
YouTube at RSU TV, and you can go ahead and ask me questions live. How fun is that? Okay, here we have another two-step equation. We have 3x plus 2 equals 23. I'm going to go ahead and write it out. Was the red showing up good? Okay. So I'm going to work out this problem in red. Not because it's a negative color, but just because I like it. So 3x plus 2 equals 23. What do you think we're going to move first? You're right. We're going to move the positive 2. And if it's positive, we do the opposite. Of course, you could look at that as plus 2. And the opposite of that is a negative 2 or a minus 2. So don't forget, whatever I do to one side, I have to do to the other. So now we're going to just do the math. 23 minus 2, simple math here, is 21. Bring down your equal sign, bring down your 3x, and once again, we're just going to do the second step. And the second step of a two-step equation is any multiplication or division. And you're going to hear me be repeating those steps a lot because, like I said last week, repetition helps ingrain it into our brains, okay? So we're going to divide both sides by 3. And I'm going to write my answer over here. So we have x equals 21 divided by 3, which is 7. Now, I thought a bit about this last night, and there is a lot of, not controversy per se, but allowing calculators in the classroom. And this is my personal philosophy on that. Whenever I come to a new concept that requires mental math, I always like the kids to try a few problems without the assistance of a calculator. Once they've shown that they can master that, then I will throw that calculator in there. There are some lessons where we just go straight to the calculator because the concept isn't solely about multiplication or division. So remember, your calculator isn't your brain. It's an assistive tool for you to use to bridge that gap if you're stuck on something, okay? All right, ooh, math rocks. Why? Yes, it does. Okay, we have, oh my goodness, we have a different variable and it's in a different location. What do? We solve it like we normally would. Don't let a math problem that looks different mess with your brain. You still have only two steps, addition and subtraction or multiplication and division. So I'm going to go ahead and rewrite this problem, and we're just going to get after it. Okay, so we have 6 plus 5y equals 26. Now, you still ask yourselves, what's going to stay and what's going to go? That's something I ask in my class. I tell the kids, okay, what's going to stay, the variable, and what's going to move? Because sometimes you might think, oh, the 26 is going to move. But then I'm going to ask you, is that on the same side as the variable? It's not. So that's how you are able to tell what is going to go and what's going to stay. So in this case, we have a positive 6. Now, I don't want you to look at the plus sign in front of the 5y because that doesn't go with the 6. Remember, we always look at the sign or in front of the number. I don't see one here, so I automatically know it's positive. So I want that to be clear. So I'm going to subtract 6 on both sides. Remember, what you do to one side, you have to do to the other. So 26 minus 6 is 20. Bring down what you haven't used, which is our 5y, and we have another one-step equation. So 5 times y, the opposite of times is division. So we're going to divide both sides by 5. And I'll write my answer over here. We have y equals, what is 20 divided by 5? 4. Now, if the order of an equation confuses you, you can always rewrite it. There's nothing wrong with rewriting an equation so that it suits your learning style. The important thing you remember is this, that you keep the signs with the correct numbers. So let me rewrite this in red, and I'm going to rewrite it down here. If I wanted to have that in what we call standard form, I would move the positive 5y to the front, and then I would make sure that I moved that positive 6 behind it. And then, of course, the equals 26, that doesn't change at all. But notice, it's a positive 5y here, it's a positive 5y here. It's a positive 6 up here, it's a positive 6 down here. Remember, you can rearrange the equation to write it to where it looks like you would normally solve it. Just make sure you keep your signs the same, because if you don't, then that's going to mess up your answer. Okay. Oh, we have a fraction here, and we have a 0. Our variables on the right side of the equation. So I'm going to solve this 2 different ways. I'm going to solve it without rewriting it, and then I'm going to solve it with rewriting it so you can see the difference. So I'm going to rewrite it over here. 0 equals 6 plus 1/3 t. So you still ask yourself, what stays and what goes? The variable stays. And so the 6 and the 1/3 are on the same side as the variable. So that's how you know what moves. It's on the right side of the equal sign does not mean that you solve it any differently. Don't let the way an equation looks fool your brain into thinking all of a sudden you don't know how to do it. So I'm going to move the 6 to the other side. It's a positive 6, not because of the plus sign, but because there's no negative sign in front of the 6. I keep stepping on something, sorry. I'm barefoot. It's not going to be a surprise to any of my kids at home because I usually kick my shoes off when I teach. I'm just more comfortable that way. So anyway, little secret of television, I guess. So we're going to subtract 6 on both sides. Whatever I do to one side, I have to do to the other. So 0 minus 6 is -6. Bring down what you haven't used, which is that 1/3 t. Now, I always tell my kids, whenever you see a fraction attached to a variable, you automatically multiply by the reciprocal. Now that's kind of a big word, reciprocal. And what that means is we're just going to flip it. And we're going to flip it what, Eli? Hopefully you're watching at home. We're going to flip it real good. And that's sort of just a silly way to remember what to do with the word reciprocal. And here we go. We're going to multiply by the reciprocal. And so that cancels it out. Here's why it cancels it out. If I have 1/3 times 3/1, and I multiply straight across, I get 3/3. Now, 3/3 simplifies to 1. If I just have 1t, you normally don't see 1t written. So that 1 sort of just goes away, which is why these cancel each other out. And sometimes that step right here isn't explained in math. I don't necessarily go through that full explanation when we're first teaching it because sometimes that can be confusing. But I do come back to it at a later time so that the kids really understand, well, how does that go away? So now you know, if you didn't before. Okay, remember, what I do to one side, I have to do to the other. So I'm going to multiply both sides by 3/1. Why did I put a 1 under the -6? Well, because that's how you turn a whole number into a fraction. Because I've got 3/1 as a fraction, and so I've got to make sure that both of my terms are fractions so I can multiply straight across. -6 times 3 is -18. 1 times 1 is 1, and of course that simplifies to -18. And if we rewrite it with a variable in front, t equals -18. Now I can hear some of you at home going, well, I don't have to have that 1 under the 6, and I don't have to have that 1 under the 3. And you would be correct, but when we're talking about middle school math, it's good to show every little step because we're not at that advanced stage yet, and it's important that your teachers know that you know exactly what you're doing. Remember, don't skip the simple stuff, because when you get into higher math, you're going to want to see every little detail, because you just might make one mistake, and instead of having to erase everything and start over, you can just fix that simple mistake. Yeah, absolutely. Okay.
Is it necessary to put parentheses around a negative number when it's near the equal sign? Repeat that question.
Okay, so Ms. Park wants to know, is it necessary to put parentheses around the equal sign, right here? So is it necessary to do this? And my answer is no, it's not necessary. And here's why it's not necessary, because the equal sign is not an operation. It just represents, it represents the word is. T is negative 18. Now, if we're talking about a negative inside of a problem, like next to a plus sign or a minus sign, then yeah, you do put parentheses around it, because that shows that this isn't acting as an operation. This is attached to a whole number. Does that answer your question, do you think? Okay, good. Okay, I'm going to go ahead and erase this part down here. And I'm just going to rewrite the problem so you can see what that would look like. So the first thing you're going to do is you want your variable in front. So I'm going to take my positive 1/3 t and put it in front. Because remember, what we're doing right now is we're rewriting the equation so it looks like something familiar to you, because your brain's going to play tricks on you. We don't want it to do that. Now what we do is we write the constant. And the constant in this equation is 6. It's a positive. So we're going to put plus 6. And then, of course, it equals 0. So that is how you can rewrite the equation and make it look like something that's not so confusing. Do you have to do this? Absolutely not. Unless your teacher requires it, because remember, teachers will require different things of their students, and there's not a wrong way, just a different way. Okay. Yes. 3 minutes. Well, hello, Gage.
And Gabe.
Oh, Gabe. Oh, hi, Gabe.
Brody Brownlow says hi.
Hey, Brody. Hope you're reading up on your math history. Oh, that's my mom. Hi, Mom. Hi. Okay. So, yeah, I'm known as Nikki in my family. I don't use it as my professional name. Okay, so we've come to a blank slide. And what I want to do is I want to rewrite that last problem. And I'm going to rewrite it this way. 1/3 t plus 6 equals 0. And this will be our last problem of the day together. You are usually not going to be taught what I'm about to teach you, because it is more steps. But what I have found is that some of my students actually like this way better. And I'm going to show you what I'm talking about here in a minute. We're still going to move our positive 6, and it's going to become a minus 6. Rewrite what we didn't use. Okay. Now, if you forget that 1/3 t means to multiply by the reciprocal, there's a different way you can do it. Stay with me. This also says 1 divided by 3. What is the opposite of division? Or, I'm sorry, yeah, the opposite of division, multiplication. So I'm going to multiply both sides by 3. And I get 1t equals negative 18. Now, 1t means 1 times t I'm going to divide both sides by 1, and I'm still left with t equals negative 18. The reason why this is a good way to show your students, or even to try this at home, is because you don't have to remember to multiply by a reciprocal. This is a little bit longer, but you still get the same answer, and that's what I love about math. There are so many different ways to solve problems, and don't be afraid to try something new or to see, maybe I can solve it in a different way. And what I tell my kids, as long as you show your work and you get the correct answer, I don't care how you solve it. You might discover something new. So next week, we are going to dive into something new. We're going to talk about multi-step equations, and you're going to see some distributive property, putting like terms together, and I think it's going to be fun. So don't forget, practice these things at home. You can rewatch the video. You can ask me questions on my email account that's attached to my website at sequoiaheagles.net. If you're in my class, don't forget, you can reach out to me at Google Classroom. And I hope you guys have a great week. Be safe.